Hi everyone, welcome back to my channel. I hope you are doing well. This is the second episode of Generative AI Series, where we dive deep into the fascinating world of generative AI application. In the last video, we covered the basics of GenAI, including what is generative AI, what are the large language models, and what is the different levels of GenAI applications. If you haven't watched that video yet, I highly recommend to check on the first because it lies on the foundation of the today's discussion. I will provide the link in the description below. Please check it out. Now in today's video, we are going to explore the tool stack required for building the GenAI applications. Now in today's video, we are going to explore the tools required for building a GenAI applications, why orchestration frameworks are essential, and high-level concepts of RAG, nothing but Retrieval-Augmented Generation. And finally, the comparison between RAG and fine-tuning the LLM. By the end of this video, you will have the clear understanding of how to choose the right tools and the framework for the GenAI applications. So without wasting time, let's get started. What is the one application that comes in your mind when you think of generative AI? Let me know in the comments below so that we can now have that vast knowledge of what the generative AI is. Let's begin with the tool stack required for building a GenAI application. As we discussed in the last video, level 3 applications are production grade system that includes several components. Here is the breakdown. First thing, external APIs. This API can be OpenAI or Hugging Face APIs, or also have the APIs of datasets or the external search APIs, so that these datasets can be included in the LLM applications. Next is LLM modules. These are the core engine of the powering your application. Example including GPT-4, Llama models, or the cloud by the Anthropic. Next is cloud storage, used to store and manage the large datasets and generated output. Example AWS S3, Google's cloud storage, or the Amazon Blob. Next is the vector database. This database stores the embeddings, nothing but the numerical representation of the text, and enables the semantic search on this representation. Example Pinecone, Vivint, or Mavels. Next, backend frameworks and several. Handling the logic and processing the behind your application uses the backend frameworks and the servers. For example, Flask or the Fast API for the Python-based application can be used. Next is a front-end framework or the server. Provide the user interface for the end user to interact with your application. For example, the React.js or the Angular can be the web app for your front-end application. Next is orchestration frameworks. These frameworks helps to manage the workflow between the different components like LLMs and a database or a vector database. Example, LangChain or a Llama Index. Next is a cloud deployment. A platform like AWS, Azure, or a Google Cloud allows you to deploy a scalable your application efficiently. You might be wondering why we need the orchestration framework. Well, orchestration frameworks act as a glue that connects all the components in your application. They simplify the complex workflow by automating the tasks like calling the APIs, managing the database, and processing the input and output. This you will get understand when we go to the hands-on project. For example, in the chatbot application, an orchestration framework like LangChain can handle the tasks like retrieval context from the database and passing it into the LLM to generate the response. Without orchestration framework, managing these workflow manually would be the time-consuming and error prompts. Next, high-level concepts of RAG application. Now let's talk about the RAG, Retrieval-Augmented Generation, a powerful architecture that overcomes some limitation of the traditional LLMs. So what is the limitation of LLMs? LLMs cannot provide the accurate answers to private or proprietary data because they are trained on a public database. They may not have the access to up-to-date information since they are trained on the data that are static. So these two are the major drawback from the traditional LLM. This can be overcome from the RAG architecture. This can be overcome from the RAG architecture. So what is the RAG architecture? RAG combines the two key components. So what is the RAG architecture? RAG combines the two key components, that is the retrieval system and the LLM. A retrieval system that fetches the retrieval information from the external source like vector database or internet, and the LLM that uses the retrieval information to generate the accurate and contextual awareness response. You can think like the RAG as a library plus an author. A library finds the most relevant book for the reference, and the author reads those books and writes the custom response for the generation. The main four components of the RAG architecture are vector database, retrieval module, LLM module, and orchestration framework. Vector database stores the embedding, nothing but the numerical representation of the text to fast retrieval of the relevant data. It can be Pinecone or Malverse. And retrieval module fetches the relevant data from the vector database based on the user query. And the LLM models generate the response using the retrieval data and its own knowledge based on the trained. Orchestration frameworks manage the interaction between the components like vector database or LLMs. Now, you may get the question, what is the difference between the RAG and the fine-tuning? So when we compare the RAG and fine-tuning, the data handling RAG uses the external data dynamically, while the fine-tuning requires the retraining every time. The cost efficiency of the RAG will be the very less compared to the fine-tuning, because fine-tuning requires expensive number of GPUs. Flexibility is highly flexible with the architecture, and fine-tuning has a limited once it is trained. Use cases ideal for the private or custom database or based on the domain specific task. In summary, the uses the RAG when you need the dynamic access to private or frequently changing data, and use the fine tuning when you need the element specific to specific domains or a task. You may get the question that how to choose the best orchestration frameworks in the industry. When selecting the orchestration framework for your project, considering the ease of integration with LLMs and the database, and scalability of highlighting and a large workflow, and community support and documentation for the future reference and compatible with your tech stack. For example, LangChain is a great if you are working with a Python based application or a JavaScript application. Llama Index is ideal for your need and advanced indexing capability for retrieval in task. Let's recap what we have covered today. In today's stack, for example, application includes APIs, LLMs, vector database and cloud storage, front-end and back-end frameworks, and orchestration frameworks, and a cloud deployment. The orchestration frameworks simplify the workflow management by connecting the various components seamlessly. Then the RAG addresses the limitation of traditional LLMs by considering a retrieval system with the generating modules. Choose between the RAG and fine-tune based on your project needs. RAG is dynamic while fine-tuning is static but specialized. With these insights, you are now better equipped to start building your own GenAI applications. Thank you so much for watching. If you found this video helpful, please give thumbs up. It really motivates me to create more content for you. Don't forget to subscribe to my channel and hit the bell icon so that you don't miss any episode in the GenAI series. Now here is my question for you. Which orchestration framework are you most exciting to try? LangChain or Llama Index or any other? Let me know in the comments below. In our next video, we'll dive deeper into the RAG architecture and orchestration framework like LangChain with a hands-on example. Until then, keep exploring, stay updated for all the things in AI. See you in the next video. Bye bye.